Electron Configurations 2. How to write the noble gas configuration. Let's do the configuration of polonium, atomic number 84. We start with the 1s subshell as always. 1s, 2. 2s, 2. 2p, 6. 3s, 2. 3p, 6. 4s, 2. 3d, 10. And it seems we have run out of space to draw things this large. So we need to make them smaller. After the 3d10 comes 4p6, 5s2, 4d10, 5p6. Let's stop and add up the number of electrons we have shown already before we go too far. With 1s2 we have 2 electrons. Adding the 2s and 2p adds 8 more, so after the 2p we have 10 electrons. Adding the 3s and 3p adds 8 more, so after the 3p we have 18 electrons. Adding the 4s makes 20, the 3d makes 30, and the 4p makes 36. Adding the 5s makes 38, the 4d makes 48, and the 5p makes a total of 54 electrons. So to make 84, we need 30 more electrons. We need to once again make things a little smaller before continuing. After the 5p comes 6s2, giving us 56 electrons. 4f14, a total of 70, 5d10, 80, and 6p, which could hold 6, but we only have 4 more electrons, so it becomes 6p4. You can see that for the elements in the bottom of the periodic table, the configuration becomes rather long and involved. It would be nice if we had a shorter way of writing it and giving the same information the full configuration gives. There is a way to do this, but first let's look back at the filling order. If we look at the total number of electrons present when we have filled up through certain points in the list, we see that after the 1s subshell we have 2 electrons. Filling the 2s and 2p gives us 8 more, or a total of 10. Filling the 3s and 3p makes a total 18. Filling the 4s, 3d, and 4p makes a total 36. Filling the 5s, 4d, and 5p makes a total 54. Filling through the 6p makes 86. And filling through the 7p would make a total of 118. If we look at the periodic table, we find that these numbers are the atomic numbers of the noble gases: helium, neon, argon, krypton, xenon, radon, and the as yet undiscovered element ununoctium. To shorten the configuration, we can allow the symbol of a noble gas to represent part of the configuration. We choose the noble gases because they are at the end of the row, and because all of the occupied subshells are filled. Just as we found writing the configuration to be a lot shorter in time and space than drawing orbital filling diagrams, we now have a shorter way in time and space to write the configuration. It is called the noble gas configuration. So, let's try the problem again. Only this time, let's write the noble gas configuration. We start with the periodic table. We locate the element in the table. There's polonium. Then we locate the noble gas in the row above the row the element is in. This is xenon, and that is the noble gas we will use in the configuration. We start by writing the symbol of xenon in parentheses at the beginning of the configuration. Now we need to determine where to begin filling in the rest of the configuration. We know that xenon has 54 electrons. This means that its configuration has filled every subshell through the 5p. So we know that the next electron will go into the 6s subshell. Next, we need to know how many more electrons we need to enter into the configuration. Polonium has 84 electrons. Xenon has 54. That leaves us with 30 more electrons to put into the configuration. So we continue with 6s2, 4f14, and 5d10. This is 26 of those 30 electrons. That leaves us with 4 to place in the 6p subshell, which can hold 6. So the configuration ends with 6p4. Let's do another example. Write the noble gas configuration of berkelium, Bk, atomic number 97. We again start with the periodic table and locate the element. Here it is. One of the quirks of this form of the periodic table is that the two rows that are placed at the bottom of the table are actually part of other rows. The upper one is part of row 6, and the lower one is part of row 7. So we look for the noble gas at the end of row 6, radon. We start off with the radon symbol in parentheses. Next, we determine that there are 97 minus 86 equals 11 remaining electrons. And we start by adding 2 electrons to the 7s subshell because radon fills through the 6p. We are left with 9, but the next subshell, the 5f, can hold 14. So we end the configuration with 5f9.